Yeah, we better to recall whatever we did in the binomial distribution, and we have to apply that one, isn't it? Okay. Occurrence and non-occurrence. Okay. Success or failure. Okay. In that kind of situation, suppose P is the probability of success and Q is the probability of failure. Is that okay? Let me take like that. Or occurrence and non-occurrence. P is the probability of some occurrence, Q is the probability of some non-occurrence. Okay. So success, failure. Then after n trial, okay, after n trial, probability of n1 success or R success. Am I right? That's what we have written. After n trial, probability each of the event have got only success and failure. Okay, only two possibility. So after n trial, probability of R success, that's equal to NCR P raised to R Q raised to n minus R, isn't it? This is what we have seen. Binomial distribution. Why binomial? Because this is a binomial term. So this is a term in the binomial expansion of P plus Q whole power n. Yeah. Now look at here. We shall try to apply this one. So to the situation. So there is a person who has taken so much alcohol, okay, and who is doing random walk. Okay, we call this as random walk problem. Okay, random walk. Okay, so that means again, so you have to model this one like this. Okay, so there is a lamp post here. That okay, there is a lamp post here. So it's a one-dimensional random walk. Yeah, speak out. Yes. So again, now look at here. This is a one-dimensional problem. So there is a lamp post here. Let me take this one as x equal to 0. Okay. So a drunkard or a person who has taken so much alcohol. Okay. He is taking steps here. Okay. From here, it again he will either move right side or left side. Is that okay? Or forward or backward. You can say like that. Okay. So each of the step again he can take a step of length L. Okay. Each of his step is of length L. Okay. So now let me draw that one like this. Is that okay? This is x equal to 0. So now he can move either in this direction or in this direction. Is that okay? One dimensional problem. Okay. One dimensional problem. He can move either right side or what do you call left side. Okay. Let me take somewhere here he got his home. Is that okay? Is that okay? Somewhere here he got his home. Okay, this is x equal to 0. So the each length is L. Okay, each step length is L. So shall I take like this? Like this. Is that okay? Suppose let me assume like this. Suppose if he takes a step to the right. Okay. Let me take right and left because we are seeing like this. Am I right? This is our right, this is our left. Okay. Or for him it is forward, backward like that. Okay. Only two choices here. Okay. He can take step to the right or left. Okay. Now let me take, if he has taken step to the right, let me take that one as a success because he is moving towards his home. Okay. If he takes step to the left, let me take it as a failure. He is moving away from the home. Okay. So he has taken so much alcohol that he is struggling to get into home. Okay. So let me take that situation. Now look at here. In this situation, let me define a P as probability that step being taken to the right. So can I define like this? Probability that step being taken to the step. So how can I write? Probability that step to the right or wait a second, let me read out. Probability of step being to the right. Probability of step being to the right. Okay, let me call this a success. Okay, because he is moving towards home if he has taken what you call step to the right. Okay, So let me define 1 minus P or Q, which is probability of step being to the left. Let me call this one as failure. Okay, let me call this one as failure. And he has started from x equal to 0. Okay, this lamp post, he has started from x equal to 0. So now question is, okay, after some step, okay, after some step, after some n step, okay, after n steps, what is the, again look at here, if he has taken n step, okay, he will move a distance along x-axis. Let me take this one as positive x-axis, this one as negative x-axis, isn't it? After he has taken n step, he may move along either positive x-axis or negative x-axis, okay, and his displacement will be x equal to m into L, where L is the, what you call, length of each step. Can I say like this? Again, where m is integer, isn't it? After some step, again, he should be in the position along x-axis where x equal to m into L. M can be either positive or negative, isn't it? Because each of the steps are of length L, isn't it? Now, how do you grab that m? So now let me take out of this n step, speak out. Out of this n step, no, wait a second. Again, he has taken total n step. I didn't say this is right or left, okay? Now let me divide. Out of this n step, let me take n1 step to the right, okay, n2 step to the right, to the left. Is that okay? Where n1 plus n2 is equal to n. Is that okay? n1 plus n2 is equal to n. Total number of step is capital N, okay? Out of this, that n step, n1 step to the right, he has taken n1 step to the right, n2 step to the left. Is that okay? Now, how do you write this m now? If n1 equal to n2, if number of step to the right equal to number of step to the left, he will be back at the origin, isn't it? Average. No, don't say average. Average means we have to do much more trials, okay? Wait a second. If number of step to the right is equal to number of step to the left, then he will come back to the origin, am I right? So he will take as many steps forward, as many steps backward. Again, he will be back at the origin, isn't it? So that's why we can write like this: x is equal to n1 minus n2, n1 minus n2 into L. Can I write like this? If n1 is greater, okay, or what I have done here is I have written m is equal to n1 minus n2, okay. Why I have written this one? Because look at here, if n1 is greater than n2, okay, if number of step to the right is greater than number of step to the left, he will have positive displacement along positive x-axis. Am I right? He will be somewhere in the positive x-axis. If number of what you call step to the left is more, then this is negative. Am I right? Then he will be displaced along negative x-axis, isn't it? That's why I have taken n1 minus n2. You can take n2 minus n1 also, but I have taken n1 minus n2 because I have taken this one as positive x-axis. Okay, if number of step to the right is more, then this whole thing is positive, so that he will be displaced towards positive x-axis. If number of step to the left, if it is more, okay, then he will be displaced towards negative x-axis, because this quantity will be negative in that case. Okay, so that's how I have fixed that one. Now look at here, after n step, he will be somewhere here, isn't it? Somewhere at this position. Okay, now the question is, look at here, after n step, okay, I hope you have noted down these things. After n step, look at here, let me speak of this one, okay, let me speak of this one, and let me write the statement in the mathematical, okay. The question is, after n step, after the man has taken n step, okay, can you write down, after the man has taken n step, what is the probability of his being at x is equal to m into L? After n step, after n step, what is the probability of his being located at the position x equal to m into l? Can I write like this? After n step, what is the probability of getting him at this position? Is that okay? At this location. So now, again, how did you get this one? Look at here. So this probability is equal to, after n step, so m is equal to, again, after n step, probability of getting m, because m will decide x, isn't it? So now, this probability is equal to, after n step, so n2 minus n1 is equal to m. M is equal to n2 minus n1, isn't it? Is that okay? That means probability of locating him at x equal to m into l after n step, that's equal to probability of getting this m, isn't it? Are you getting it? Because m will decide this one. So now, how this m depends on what quantity m depends on? M depends on n2 and n1, isn't it? No, m doesn't depend on both n2 and n1. You just check out. Look at here. n2 and n1 are related to capital N, which is constant. So that's why what I can write here is m is equal to, I can write, n1 minus n2. What I have written? Speak out. n1 minus n2. What I can write here is, I can write n2 is equal to n minus n1. Am I right? So that I can write m in terms of n1. n2 I can write in terms of n1, am I right? So that's why m depends only on either n1 or n2, not both actually. Check that out. Because n1 plus n2 is equal to n, these are dependent. Is that okay? Speak out. So that's why, look at here, what I can write here is n1 minus n2 is n minus n1. What is this one? Speak out. 2n1 minus n. 2n1 minus n. Is that okay? Probability of locating him at x equal to ml after n step, okay? That's equal to probability of getting m, that's equal to probability of getting n1, can I say like this? n1 step to the right. After n step, probability of getting n1 step to the left, because n1 will decide m, isn't it? So that's why this probability, I'm going to write it as probability after n step, n1 step to the right. So can I say like this? Now it is our binomial distribution. So let me take step to the right as success, am I right? Probability after n trial, n1 success, n2 failure. Is that okay? Speak out. It's very simple. So this is equal to, yeah, speak out.
How you have written the last can you explain again?
M is equal to n1 minus n2. From this equation, n2 is equal to n minus n1.
After that,
Now, n1 will decide m, am I right? Probability of getting m, some particular value of m, that depends on probability of that is equal to probability of getting some particular value of n1. Isn't it? n1 is deciding m, isn't it? Speak out. n1 is deciding m, isn't it? That's why if you got n1, if you got some particular value of n1, you will get corresponding value of m, isn't it? Speak out. So that's why this is equal to n1. So probability after the n step, n1 step to the right, okay? That means if n1 step to the right, this much step to the left. We know, because capital N we have taken that one as constant, okay? Number of steps, okay? So that's equal to n1, probability of success, isn't it? Or probability of step being right, isn't it? P raised to n1, so q raised to n minus n1, or you can write 1 minus p here, isn't it? This is equal to 1 minus p here, yeah. I have written x is equal to m into l. Then what is this m again? So this m should be equal to n1 minus n2, that's what I have written. If you can take it, then you have to take a positive x-axis along here, negative x-axis here, that's it. If n1 is greater than n2, this is positive. If number of steps to the right is greater than number of steps to the left, he will move towards positive x-axis. X, I have taken variable x here, am I right? X is either positive or negative. According to that one, I have chosen m. Is that okay? Yeah. Speak out. Now, n minus n1. So we can write it like this: n factorial divided by n minus n1 factorial into n1 factorial, okay, p raised to n1 q raised to n minus n1, okay. So you can write as n2 also, am I right? N minus n1 is n2, n factorial divided by, again you can write this one in very different way, am I right? You can write this one as 1 minus p, isn't it? This one as 1 minus p, like that, okay. So there are different ways of writing this one. This is n2 factorial, isn't it? N minus n1. Speak out. I have written directly, okay. In Riff he has done the derivation of this one, okay. Check that out. So now look at here. Why are we studying this one, isn't it? Because again, why do we study the person who has taken alcohol, who is struggling to reach home, isn't it? Why it is required, isn't it? So now our aim is not to study this one. Look at here. You better to mention some point, okay. The similar situation it comes in case of magnetism. Suppose if you have a solid which contains all spin half atoms, okay. If you place that one in external magnetic field, each spin half atom either align parallel to the magnetic field or anti-parallel, am I right? All spin half atom which aligns parallel to the magnetic field, it will contribute to the magnetization, am I right? So shall I say like this, isn't it? Suppose if half of the atoms are parallel to the magnetic field, other half are anti-parallel to the magnetic field, there will be no magnetization, no net magnetization, isn't it? Here also, if number of step to the right is same as number of step to the left, there will be no net displacement, isn't it? He will not move towards home or away from the home, isn't it? He will be at that position only, isn't it? At the same, so in the very same situation, I have a what you call solid, okay, which contain all spin half atoms, okay. I am placing that one in the external magnetic field. So then each atom have got two choice here. Is that okay? Now wait a second. Before getting into that one, I need to give you one more idea here, because here it's not one atom which is doing different thing, isn't it? Here you have n atom, isn't it? Suppose let me take n atoms here, okay. Now look at here. One thing that you need to convince yourself here is, okay. So this is whole binomial distribution, okay. Now how do you verify this probability after n1 step to the right, isn't it? That's equal to n(c)(n1) p raised to n1 q raised to n minus n1. N minus n1 is n2, isn't it? How do you verify this probability? Quickly. Again, in case of we have solved one question, isn't it? Pen manufacturing something, isn't it? How do you verify that probability? What was that question? 12 pens are manufactured like that, am I right? 12 pens are manufactured, isn't it? 1 by 10 is the probability of being defective, isn't it? And again, so out of 12, what is the probability that 1 is defective, am I right? After 12, 1 is defective, that's equal to probability of being defective raised to 1, probability of being non-defective raised to rest of the power 11, isn't it? Now, okay, you found some value, okay, this is some value. How do you verify that one? Practically, speak out. Can you recall yesterday's problem? 12 pens are manufactured, okay. 1 by 10 is the probability of being defective, okay. After 12 of such pens are manufactured, what is the probability that one pen is defective? Is that okay? Speak out. Now you found that one, am I right? After 12, what is the probability that one pen is defective after 12 pens are manufactured, am I right? You found some value here, 0 point something, isn't it? Now how do you verify that value? Quickly tell me. How do you verify any probability? How do you verify probability of being head or tail?
By taking repetition terms.
Practically, not sample space. So this is over. This mathematics was over here. Okay. Practically, how do you verify that one? You have to take repeated thing, isn't it? That means you need to manufacture 12 pens billions of times, isn't it? You need to manufacture 12 pens. Yeah, speak out. That's correct. You need to manufacture 12 pens millions of times. Okay, each of the time you have to count how many pens are defective. Okay, so and you have to count how many number of times you got one defective. Okay, 12 pen manufacturing. Let me take that one as one thing. Okay, and you have to do that one millions of times. Okay, and each of the time you have to find how many pens are defective. And you have to count how many times you got one pen is defective, and you have to take the ratio with the total number, isn't it? Then you will get you can experience this one. Am I right? So similarly, how do you verify this probability, isn't it? That means you have to make him to do random walk of n step millions of times, isn't it? So then you have to take the ratio. Okay, how many times he got n1 step to the right? But we can't do that one with one person, isn't it? He may die, isn't it, after some time, after some trial, isn't it? Practically, it is not possible. Now, how do we design this problem here is, again, so since we can't do the same trial with a person, okay, I mean practically, so he can do again, so he can, again, with one person we can have n step, okay. So now what I do is, let me take millions of persons, or what I do is, let me make similar track, okay, millions of track, similar to this one, let me make millions of tracks, and I'll take millions of person, okay, all of them again have taken same amount of alcohol, so that probability to the right and left which are same for all of them. Is that okay? That is not changing. Is that okay? So now look at here. In that situation, again, if I take millions of people who have started from here, all of them together take n step, okay. Now what is the fraction of the people who has taken n1 step to the right, isn't it? So that's how you verify that one, isn't it? Are you getting my point? That means, look at here, one person, how to write this one? One person, again, what I'm trying to write here is, I'm trying to write one equality here. Is that okay?
Millions of person, one thing.
Again, yeah. So, 100 people taking n step once, okay? Okay, that's equal to one person taking n step, okay, 100 different times. Tossing one coin 100 times is same as tossing 100 coin once, isn't it? I mean, to verify the probability, so we can take this equality, am I right? Actually, this should be million. To verify this one, this should be very high, isn't it? So then only we can get that fraction very, very well, isn't it? We have seen that one in case of probability of being head and tail, isn't it? So that's why one person taking n step, okay, 100 different times, okay, that is equal to 100 people taking n step once. Is that okay? So here you count, okay, how many times he got n1 step to the right. Here you count how many people, because this 100 people taking n step once, am I right? Only one time. Here you count number of people. Here you count number, isn't it? How many times? So that person have taken n1 step to the right, isn't it? What you do here is, here you count how many people have taken n1 step to the right. Both are equal, isn't it?
Sir,
Yeah, speak out. Again, just like tossing one coin 100 times, you count how many heads, am I right? Tossing 100 coin once, you count how many heads, am I right? Like that, okay? So try to compare that one. So now actually this should be million, okay? This should be very high, so that we can experience this one, or so that we can show this one in a particular situation, okay? Now our application is here, not here, okay? In our application, we will take this situation actually. Is that okay? We have 100 people taking n step once. That means we have n atoms, okay? each of the atom either parallel spin up or spin down along external magnetic field. No. 100 people, each of them, 100 people, each of them taking n step once. Speak out. I'm not defining anything. Try to grab this equality. Tossing one coin 100 times is same as tossing 100 coin once. Isn't it? So that's what I'm saying. Doing experiment with one person 100 times. Again, so to validate this one, you have to do repeated trial, isn't it? That trial you can do with one person, okay? That trial you can do with 100 people. Are you getting my point? Speak out. In case of this 100 people, okay, you have to count number of people who has taken n1 step to the right. Here you have to count how many times this person has taken n1 step to the right, okay? Since we can't do this one, we go for this number, right? Again, these are all thought experiment, okay? We don't go for this one, okay? But our application comes here, okay? Our application comes here. Suppose if you take a magnetization situation, okay? You have n atoms. Each atom can align either parallel to the magnetic field or anti-parallel to the magnetic field, okay? All of them are acting once, am I right? All of n atom, okay? Quickly placed in external magnetic field, isn't it? Speak out.
Sir, probability will change if the road is like uphill or downhill.
Yeah, so definitely. Now again, this probability depends on many things here, okay? Suppose if you take this funny situation of a drunkard, okay? Suppose here if he has taken less alcohol, he may move towards home, am I right? There is more probability that he may move towards home, okay? Or he has taken so much alcohol that probability being right and left are equal. You can make like that. Or you can make this road quite inclined so that probability of being at home, it is more, isn't it?
But that
More.
you can say biased, right?
Yeah, kind of biased actually. Is that okay? So again, P and Q, again, P plus Q is equal to 1. So P and Q can be anything. That can be half and half or unequal, okay? That can be anything. Now, so I want you to understand this situation, okay? To verify this one, you can either go for this one or you can go for this one, okay? That's what you need to. Now, the real application of this whole problem is in case of magnetism, okay? So, suppose there are n atoms, okay? Which are, again, each atom that can align either parallel or anti-parallel to the magnetic field, isn't it? So, if you take n atom, okay? So, then each of the atom can, what you call, or can I do like this? Wait a second. Can I do like this? Is one way to verify this one. Am I right? I told how to verify this one, isn't it? Wait a second. I'm trying to get one idea here. Yeah, that's correct. Okay, that's correct. This idea is to verify this one. Okay. Now to formulate this one, let me slowly modify this one. Okay. Let me slowly modify this one. How do I do this? Look at here. One person taking n step. This is not to verify this one, okay? This verification is over, okay? By taking millions of people who are doing random walk once, okay? One person taking n step, okay? Now let me make that one as equivalent to n people taking one step. Okay? It is not to verify this one, okay? It is to what you call connect this one to magnetism. Isn't it? One person taking n step. N people taking one step. So can I say like this? But here again, this is again, I am trying to connect this one to this magnetism. So that's why I'm taking this idea. One person taking n step, look at here, what you call, what is the probability of net displacement? Am I right? That's what you say? Speak out. That means x is equal to m into L, where m equal to n1 minus n2. Am I right? This is what you say. Ask here. Now here, what is the probability? Again, now you have to take the summation of number of so again there are n people taking one step. Each of them are so taking one step here. You have to sum the number of step to the forward, number of step to the backward here. You have to make the summation. Is that okay? Now look at here. So now let me write n1 is equal to summation of what you call number of people who have taken one step to the right. Is that okay? So now similarly n2 is the summation here. So how many people have taken, okay, so now here n1 is number of people who have taken step to the right, n2 is number of people who have taken step to the left. Is that okay? But here n1 is number of step to the right, n2 is number of step to the left. Okay, when I write this equality, so again now here you talk about again probability of getting him at x, okay, or probability of getting this displacement, am I right? So here again what you talk about here is again, so here also you can talk about the same thing, probability of getting m or probability of getting n1 minus n2, isn't it? Now when you go to this one, okay, look at here, each of the atom have got two possibilities, am I right? There are n atom, okay, all of them together placed in external magnetic field, okay. If number of atom which are spin up is more than number of atom which are spin down, let me take n1 is number of atom which are spin up, okay, n2 is number of atom which are spin down along external magnetic field, okay. If number of atom which are spin up along external magnetic field is more than number of atom which are spin down, then it will have net magnetization along the direction of magnetic field, isn't it? If number of atom which are spin up along external magnetic field is same as number of atom which are spin down, then there will be no net magnetization, isn't it? Now here again, here probability of getting the displacement, here similar thing. So here what is this one? Probability of getting some magnetization, which depends on n1 and n2 or n1 minus n2, isn't it?
Which will dominate.
Whether number of spin up atoms are more than number of spin down atom or not. Are you getting my point? So can you find the equality? That okay? This probability exactly same. Probability of getting m magnetization, can I write like this? M magnetization, I think I can write like this. M is equal to, I have to take per unit volume here, okay? Magnetic moment per unit volume is magnetization actually. Let me take care. Let me write that one as n1 into mu vector minus n2 into mu vector, where mu is the magnetic moment of each atom. Is that okay? So let me take plus mu and minus mu here. Is that okay? So if n1 is equal to n2, it is null vector, am I right? I have to take per unit volume, that I haven't taken care, but that's okay, isn't it? So now here the question is, what is the probability of getting a particular magnetization? What is the probability of getting him at x equal to m into L? What is the probability of getting n1 people who have taken step to the right here? Okay, each of the person has taken only one step, okay? Yeah, what is the number of people who have taken n1 step to the right? What is the number of atom which are spin up? Can you find the equality? Figure out. So this is where we apply this one, okay? Now look at here, next one. This is one dimensional random walk. So this is also one dimensional random walk. Is that okay? This spin of atom placed in external magnetic field, that's also one dimensional random walk. That's what I was trying to convey. Any question quickly? Now that is one example, okay? Other example is this random walk need not be in one dimension, am I right? It can be in two or so 3 dimension, am I right? 2D random walk. Quite difficult to handle, okay? In case of one dimension, it was binomial distribution. If you know the probability, it was binomial distribution, am I right? Yeah, speak out. Yes. Again, in case of n atom, okay, each of atom is doing one trial, either spin up or spin down according to its probability. Is that okay? Is that okay? Now what I am saying is these two are equal. That's why I have taken one person taking n step, okay, and counting number of steps to the right. That's equal to, okay, n person taking each of them taking one step, counting number of people so taken step to the right. So similarly, n atoms placed in external magnet. So here it's not, again, in the application of that magnetism, it's not one atom takes n step, am I right? That's quite meaningless.
Sir, another question. Sir, n person taking one step means all of them are starting from same point, or they may be?
Yeah. So all of them starting from the same point. And I'm counting how many people have taken step to the right, how many people have taken step to the left. That's what I have mentioned there, isn't it? Try to write that one again, okay? So try to write down whatever I have written here. N1 is number of people to the right, number of people to the left here, isn't it? Here N1 is number of step to the right, number of step to the left, okay? So there again, N1 and N2 in case of magnetism, that is number of spin up and number of spin down. And the difference, we'll talk about what we call displacement here. That difference we'll talk about magnetization there. Magnetization. Difference of N1 and N2. If N1 and N2 are equal, if number of atom spin up is equal to number of atoms spin down, net magnetization is 0.
Okay, sir.
No, again, so in case of N person, why I have taken that one? Because to match that one with the magnetization idea. Is that okay? There you can't have net displacement like that, okay? Each of them, he will be either one step right or left, am I right?
Yes, sir.
That's why I have counted number of people. So, but that difference, okay, in case of magnetization, that difference, number of spin up and number of spin down, that difference, and N1 minus N2, that will decide whether magnetization is positive or negative. M vector is positive or negative, isn't it? Or along the direction or opposite to B. Okay. So, 2D random walk problem. So, now it's again look at here. In case of 2 dimension, from a point, you have infinitely many ways to move along a plane, am I right? On a plane, you have infinitely many directions to take next step, isn't it? It's quite difficult to handle actually. It can be handled by some complex analysis. Let me share some ideas. But what I'm saying here is in case of this 2D random walk, okay, the best application is our, okay, look at here. So he has given light intensity due to n incoherent light sources. Light intensity due to n incoherent light sources. Is that okay? So now, so each of this light source and its electric field amplitude and its phase, that information can be held by 2-dimensional vector actually. And you remember this one, adding these vectors like this? Like this? Do you remember? And taking the resultant? If you have n incoherent sources, okay, I mean different phase. Okay, what is the net amplitude? What is the net intensity? So you have to take each of those sources, okay, you have to take their electric field, amplitude, and electric field phase. Phase is also important, am I right? While doing what you call addition. Now that phase as well as amplitude, that information, you can have that information by 2-dimensional vector. And you can add all of those all of those 2-dimensional vector to find resultant electric field amplitude and resultant electric field intensity. I think we do this one in optics. Anyone remember what we call this one as? Some spiral thing? Anyone? I forgot actually. So that's a kind of random walk. 2D random walk. Is that okay? Because this vector displacement, okay? So that's a kind of random walk. Here nothing is drifting here. It's all electric field amplitude and phase. Amplitude and phase information is, you can take it like this, suppose, phi. Roughly. Some spiral, it is called as some spiral, am I right? So that's a 2D random walk actually. Here nothing is displacing, but again, each of those electric field, again, and its phase information, okay? Each of the source, amplitude and phase information, so that can be held by 2-dimensional vector, okay? And adding all of those 2-dimensional vector, you will get the resultant electric field amplitude, resultant intensity when you take mod square, isn't it? That's the other idea. So then if you go for 3D random walk, you can go for some diffusion kind of thing, diffusion of some molecules and all. Is that okay? If you go for 3D random walk, okay, you can talk about diffusion of a molecule in a gas. Is that okay? These are the applications actually. Now we shall start working out the method. Again, we are restricting ourselves to 2D random walk here, isn't it? Speak up. Light intensity due to n incoherent sources. That's what again he has mentioned. You just read out that one, okay? You don't have to write that one, okay? Now again I'll go back to this random walk problem, okay? So now, so shall I rub it out? Consuming space. Okay, so P is number again, probability that step being to the right, Q is probability that step being to the left, isn't it? So let me just write P and Q here, okay? I have already written this one. So let me take n is equal to n1 plus n2. n1 is number of step to the right, n2 is number of step to the left. Is that okay? And probability after n step, n1 step to the right, that's equal to n(n)(1), okay? n(n)(1), p raised to n1, q raised to n minus n1. Okay, this is what we have seen. Okay, probability after n step, n1 step to the right, that is this one, isn't it? We have seen this. P plus q is equal to, speak up, P plus q is equal to 1. Okay, now we shall work out something here. We have seen, isn't it? We have defined m also here, isn't it? So we have defined m is equal to n1 minus n2. Now can you write the whole, what you call this Pn m, isn't it? So initially we defined Pn of m only, isn't it? So can you define this one? So I mean, so can you try to write this whole thing in terms of m? So let us try that one. This is n factorial divided by n minus n1 factorial. n1 factorial. So p raised to n1, q raised to n minus n1. Okay, this n minus n1 is nothing but what you call n2 actually. Can I write like this? Yeah. From these two equations, what I do here is I will solve it for I will solve it for n1 and n2, because this whole equation I can write it like this: n factorial divided by, this is nothing but n2 factorial, n1 factorial. Okay, so p raised to n1, q raised to n2. Now let me write n1 and n2 in terms of capital N and M. Okay, that's another way of writing the same thing. Okay, now look at here. If you add them, what you will get? 2n1, n plus m. Speak out. n1 is equal to n plus m divided by 2. Check this out. Now subtract them. This one minus this one. n minus m, that's equal to 2n2. n2 is equal to n minus m divided by 2. Okay. Another way of writing that one in terms of m, where m is equal to n1 minus n2. Okay. That will decide actually displacement. If m equal to 0, displacement is 0. If m equal to positive, displacement is along positive x-axis. If m is negative, displacement is along negative x-axis, isn't it? Pick up. Pn of m, look at here. So now let me write everything in terms of n and m. n factorial divided by, what is n1 factorial? n1 factorial is n plus m by 2 factorial, n minus m by 2 factorial, n minus m by 2 factorial into p raised to n1. What is n1? n plus m by 2. Is that okay? Into q raised to n minus m by 2. Another way of writing the same thing. Okay. So can you work out this one later? Let us take one example here. Okay. Simply to apply this one. So whenever we apply, we feel comfortable, isn't it? Look at here. Suppose P equal to Q equal to half. He has taken much alcohol, so that probability that he is taking step to the right and left are equal. Okay, suppose. Then he don't reach his home, isn't it? Yeah. Anyway, don't worry about him. N is equal to 3. He has taken total 3 steps. Okay. Now, what is the probability after 3 steps? Probability after 3 steps, 0 step to the right. What is the probability after 3 steps? 1 step to the right. Okay, this one I'm writing. What is the probability after 3 steps? 2 steps to the right. What is the probability after 3 steps? All 3 steps to the right. Speak out. We have done this one, am I right? This is exactly same as our head and tail problem. Isn't it? One coin tossed thrice. Is that okay? One coin tossed thrice. In each of the cases, that probability was half and half, isn't it? Exactly same problem. What is this one? 3C0, half raised to 0, half raised to 3, that's equal to 1 by 8. Check this out. 3C1, half raised to 1, half raised to 2, 3 by 8, 3 by 8, 1 by 8. I hope this is not a big deal for you, isn't it? P equal to Q equal to half. Probability of being right and left are equal, and he has taken total 3 steps. After 3 steps, what is the probability getting 0 step to the right, 1 step to the right, 2 step to the right, 3 step to the right? It's same as one coin tossed thrice. Okay, what is the probability of getting 0 head, 1 head, 2 head, 3 head, all 3 head, isn't it? Exactly same thing comes.
Sir,
Yeah.
yeah, probability of getting 0 steps to the right is equal to the probability of getting 3 steps to the left.
Yeah, that's correct. Isn't it? Because N1, again, so capital, again, N1 means, look at here, correspondingly, N2 is equal to N minus N1. Isn't it? Probability of getting N1 is same as probability of getting N2, which is equal to N minus N1. They are one-to-one correspondence, isn't it? Speak out. So probability of getting 1 step to the right means probability of getting 2 steps to the left. Isn't it? Only 1 step to the right means other 2 steps should be at, so towards left, isn't it? That's the basic idea. Now we shall start calculating some values, okay? So we have already seen that, again, we shall try to write only in terms of N1 as I have written here, okay? Only in terms of N1. Now, when you take the summation here, okay, when you take summation of this Pn of N1, okay, over N1, N1 is equal to 0 to capital N, okay. So that's equal to summation over N1 is equal to 0 to capital N, NC N1, P raised to N1, Q raised to N minus N1. What is this one? Quickly. P plus Q whole power N, am I right? P plus Q whole power N. This is a binomial expansion, isn't it? Now I need, so look at here, I got a probability distribution here, am I right? Probability of getting N1. That's why I can find N1 mean, am I right? How do you find this one? Summation over N1 is equal to 0 to N, okay? N1 into probability of getting N1, am I right? Speak out. Way of taking average value. I hope we have discussed this one in case of quantum mechanics. Exactly the same thing. That statistical idea is same, okay? Now we need to evaluate this one. Okay, we need to evaluate this one. Let me do that small derivation here, okay? Later I'll write the rest of the terms directly. You can find this one in the REEF textbook. Is that okay? Now what you have to do here is, let me write this one. Let me write this one. What is this whole thing? This whole thing is summation over N1 is equal to 0 to N, okay? N factorial divided by N minus N1 factorial, N1 factorial, P raised to N1, Q raised to N minus N1 into N1 multiplied, am I right? This whole summation. Now what I do here is, look at here, I got N1 P raised to N1, am I right? N1 P raised to N1, isn't it? N1 multiplied with P raised to N1 here. So this one I'm going to write it as, look at here, P into dou by dou P of P raised to N1. Check this out. Check this out. Can I write like this? It's a kind of trick here. Is that okay? Let me rewrite this one. This is n1 p raised to n1. Here n1 p raised to n1. I'll put it in bracket. Other one is q raised to n minus n1. Let me keep it as it is. Okay. So this term I'm trying to write like this. Okay. Dou by dou p as p raised to n1. n1 p raised to n1 minus 1 multiplied with one more p outside. That's n1 p raised to n1. So can I write like this? Now, since this summation is over, when I substitute that one here, this summation is over n1, okay? P is not variable. P is fixed by the initial stage. That's why I can take derivative outside, because again, I can take inside or outside, because this is summation over n1, okay? This is derivative with respect to P. Just like you do in case of integration also, isn't it? Sometimes if you have any derivative, you can take it outside if integration is with respect to something else. Exactly similar manner. What is this one? This is p plus q whole power n actually, isn't it? Don't write it as 1, okay? Don't write it as 1. Look at here. The idea is, look at n1 mean, that's equal to p into dou by dou p of p plus q whole power n. Take the derivative. Take the derivative. P into n into p plus q whole power n minus 1, okay, into derivative of p is 1. It's a partial derivative. Derivative of p equal to 1. With respect to q, it is 0, okay? So q part is 0. Pick out. That's equal to, now put p plus q is equal to 1. You will get n into p. Check this out. N into p. What you have proved here is, you have proved this expression. N1 mean, okay, that's equal to n into p. It should be obvious for you. Why? Mean number of step to the right, okay, that's equal to total number of step multiplied with probability of step to the right. Can you grab it logically? Isn't it? Mean number of step to the right is equal to total number of step multiplied with probability of step to the right. Similarly, n2 mean, can you guess? Speak out. Someone. Speak out. N into q or 1 minus p. Is that okay? Q equal to 1 minus p. Now, what is m? n1 minus n2. Isn't it? M is equal to n1 minus n2. What is m mean? N1 mean minus n2 mean. Let me rub out this part. Do it again. It is there in the book, okay? N1 mean minus n2 mean. What is this one? np minus nq. That's equal to m mean is equal to n into p minus q. Look at here. One thing that you need to understand about this probability stuff is, we say probability of getting head equal to half. That doesn't mean if you do 2 toss, definitely you will get 1 toss head, other toss tail, isn't it? I think I did explain this one many times, isn't it? So like that, suppose if p is, wait 1 second. P is equal to q is equal to half, okay? That doesn't mean if you do one trial, you will get number of step to the right equal to number of step to the left. I said p equal to q equal to half, okay? That doesn't mean if he take 2 steps, he will get one step will be definitely right, other step will be definitely left. Not like that. It's all random, isn't it? Just like go for coin experiment and try to explain each and everything. That's why if p equal to q, average displacement is 0. Can I write average is equal to x is equal to m into L. Am I right? That's what we have written. X is equal to m into L. X average is equal to m average into L. Okay. So that's equal to n into p minus q into L, isn't it? That's the average displacement. Average displacement, can I say like this? So that means when p equal to q, average displacement is 0. When p equal to q, that doesn't mean that again n1 equal to n2. Don't write like this, okay? Those are different. Now we are interested in variance. We have seen this one, am I right? Again, in case of quantum mechanics. We are interested in variance actually. That's quite, lengthy to do that step from the textbook. Okay, now look at here. I need n1 square the mean. What is this one? Pick out. Summation over n1 square p of n1. Am I right? We have seen this one. n1 is equal to 0 to n. Any function of n1 you can find once you have this probability, what you call distribution, isn't it? I hope you know this formula. So this is quite lengthy step. Okay, let me skip this step. You do it yourself. Okay, it's page number 15. Okay, it's page number 15. Let me skip that step. But you need to do this one. Okay, there are questions. Okay, so n1 square the mean, that's equal to, okay, page 15. Displacement depends on how many steps he takes right as well as left together, isn't it? Displacement is decided by this difference. That's what I'm saying. Displacement depends on the difference. If number of steps to the right and left are equal, there will be no displacement. He will be back at lamppost, isn't it? Yeah. Yeah. n1 square mean. Okay, do this one in page number 15 because questions are there. Okay, on these things. Okay, so that is equal to n1 mean square plus n pq plus n pq. Is that okay? Put bracket if it is confusing. Now again, I'm not substituting that one. Okay, I can substitute n1 mean there. I'm not substituting that one because what I need is I need mean deviation. Can I say like this? Mean deviation. Mean deviation delta n1, that's equal to n1 minus n1 mean. Can I say like this? Figure out mean deviation n1 minus n1 mean. Mean deviation square. We have done this one. Okay, with some other symbol. Okay, delta n1. Okay, if you take mean, what will happen is that will become n1 mean minus n1 mean. Okay, this is variable, this is constant. Mean value is constant. Okay, again, if you take mean value, mean of mean value is again the same thing. That's why this will become 0 actually. That's why what we do is delta n1, we square it, then we take the mean, isn't it? That means n1 minus n1 mean, the square, the mean of that one. What is this one? n1 square the mean minus n1 mean the square. Anyone? Exactly similar thing in quantum again. Be careful while writing this. Okay. So that's why we call this as variance in n. Variance in n1, that is delta n1 mean deviation square the mean. Okay, so that's equal to, look at here, n1 square the mean minus n1 mean the square. So that's equal to n1 square the mean minus n1 mean the square, that's equal to npq. We don't directly find this one. Okay, while doing this calculation, while doing this derivation, this one will automatically come and you have to take it to the left hand side. You will get variance and you can find standard deviation in n1. Am I right? Root of delta n1 square the mean is equal to root of n1 square the mean n1 mean square, that's equal to root of npq. Not over. Okay, not over. We need some more factors here. What is m? M is equal to n1 minus n2. Can I write it as 2 n1 minus capital N? Speak up, n1. 2 n1 minus capital N.
Yes, sir.
So mean deviation in n. Mean deviation. That was mean deviation in n1. This is mean deviation in m. Is that okay? Let me take like this. Mean deviation in m, delta m. Let me write it as m minus m mean. If m is like this, m mean means you have to take 2n mean like that. Okay. So this is 2n1 minus n. Okay. minus, what is m mean? 2n1 mean minus n. Check this out. Now this is equal to 2 times n1 minus n1 mean. N will get cancelled. Check this out. Be careful, be careful. So that's why mean deviation in m, that's equal to twice of mean deviation in n1. This is mean deviation in n1. So that's why, again, if you take mean of this one, that's equal to mean of this one. Mean of this one is 0. We have seen that's equal to 0. Okay, delta m mean, that's equal to 2 into delta n1 mean, that's equal to 0. Okay, then what we do? We go for calculating delta m square, okay, the mean. That's equal to delta m square 4 times delta n1 square the mean. That's equal to 4 into delta n1 square the mean. Square the mean. What is this one? Delta n1 square the mean. I have found here. Delta n1 square the mean 4 times. So npq. This is npq. This is equal to 4 times npq. Check this out. Variance in m. Okay. Variance in m. Is that okay? Now let me go for x. X is equal to m into L. Delta x is equal to mean deviation in or x mean is equal to m mean into L. Okay. So delta x is equal to, mean deviation in x is equal to mean deviation in m into L, isn't it? Now delta x square the mean. Is that it? That's equal to, speak out. Delta m square L square the mean, isn't it? L square outside, delta m square the mean. What is this one? Delta m square the mean 4 times npq. Delta x square the mean. Only L square is extra. Variance in x. Standard deviation in m, standard deviation in x. You have to take the root. That's it. Okay. Root of 4 npq. Okay. Root of 4 npq. L square inside the root. You can take L outside. Okay. Is that okay? Speak out. Can you do all of this? Required. Okay. There are questions on these things. Sometimes look at here. Yeah. Have you taken? Once you do everything for n1, rest of things will follow. Okay. He defines one more quantity. Okay. Relative width of the distribution. Let me try to convince this one, okay, using some plots or something if possible, okay. Otherwise, this physical quantity cannot be interpreted properly, okay. That's equal, look at here, delta n1 square the mean, am I right? No, wait, sigma, not this one, sigma n1, okay, divided by n1 mean. Sigma n1 divided by n1 mean. So what is sigma n1? Root of npq. What is this one? N into p. Isn't it? N1 mean. That's equal to 1 by root n. Root of, I think, q by p. Check this out. If p equal to q, it's equal to 1 by root n. Let me try that one, okay. I have to plot something, then only we can experience this one. When n is very large, that relative width of the distribution is small actually.
Which means
Hmm?
what width you are saying?
I mean, width means, look at here, if you plot this one with respect to different n1, you will get a histogram actually. So he has given that one, just see that one, figure 1.41, okay? Huh. Again, if you for different n1, this whole quantity is different, am I right? For a particular choice of p and q. If p equal to q, what will happen is it will be symmetric about some middle point. It will have one middle point where it will be symmetric about that point, okay? If p not equal to q, it will be non-symmetric. You better take one simplest example, just like 3-step, and try to plot that one. Is that okay? 3-step, try to plot that one. That's the best idea.
Sir, if we take n tends to infinity, then the distribution is like continuous distribution.
Yeah, that will become Gaussian distribution. We shall see that one. That will become continuous as well as Gaussian distribution actually. We shall see that one when n is too large. So, I mean, when n is large, what will happen is about some middle value, mean value, okay, it will fall off quickly actually. This will talk about relative width, am I right? So again, you will have one mean value, about that one it will fall off quickly, okay? So you have to draw p of n1 versus n1. You will have some points here, isn't it? Height is the probability along with the number of steps. Here it is 0, 1, 2 and so on up to n here. Possible values of n, isn't it? Draw that one. I think there you can experience this one, okay? Another quantity. I think that's sufficient. The next thing is to apply this one. Apply this whole idea. Yeah. Let me upload some homework, then I will upload problem solving sessions, okay? First you need to try that one, okay? Today you try that one. I will give tomorrow as a deadline of that homework, okay? So first you try that one. By evening I will upload some problem solving session on application of random walk problem, okay? Yeah. Do all of these mathematics again because these are required, okay? There are questions on this one, okay? Can you quickly take one question, small question here? Very simple. Consider n equal to 100 step, okay? Example, n equal to 100 steps. P equal to Q equal to half. Yeah, one thing that you need to remember, note, sometimes m itself we call, again, x is equal to m into L. This is displacement, am I right? But sometimes they call m as displacement. Because, yeah, again, this L is same, isn't it? Once we fix that one. They call m as displacement. For again, you take L is equal to 1 unit. Then m itself is x, am I right? So that's why sometimes they say m as displacement. Okay, have a note on this one. Sometimes they don't mention, they will not mention L is unit displacement, okay? L is unit. So then L is unit value. Then again, sometimes you need to take m as displacement. Look at here, this is the one problem regarding that, okay? N equal to 100 step, P equal to Q equal to half. Then the mean value of N1. What is N1 mean? N into P, that's equal to 100 into half, 50. N2 mean, that's also 50, isn't it? M mean equal to 0. N1 mean minus N2 mean, isn't it? 0. But he called that one as displacement, okay? Root means square deviation of the displacement. Yeah, this one is called as root mean square, okay? Delta m square the mean under root. This sigma m. root mean square displacement. Look at here. You need to grab this word, okay, from the textbook, because in exam they use that word, okay. Root, I told standard deviation, isn't it? Look at here. Another name is root mean square. Root mean square deviation. Root mean square deviation of displacement. Root mean square deviation of displacement. This is another name for this one. I mean, actually, we should talk about x. X is a displacement. Sometimes they say m is a displacement. This is a root mean square deviation of the displacement. Yes, speak out. Standard deviation only. This will always happen. This displacement that depends on individual thing, isn't it? We have seen even again individual trials actually. It depends on individual trial actually. Are you getting my point? Look at here, value. Look at the value. What is this one? Root of 4 times npq. This will never be 0. Isn't it? That will never be 0. So you are thinking n1 number of step to the right equal to number of step to the left. Am I right? That is one of the situation, isn't it? You have to do repeated trial, isn't it? Then what is the, what you call, this will talk about the, what you call, width of the distribution, isn't it? Yeah, let me try to come out with some graphs or something, or just look into book. You'll get some idea. What is this one? So that's equal to root of delta m square the mean, that's equal to root of 4 times n pq, p into q, 1 by 2 into 1 by 2, 4 got cancelled, the root of 100, that's equal to 10. Simply we call it as displacement, okay? Actually, this should be multiplied with that unit length actually, or length of one step. But simply we call it as root mean square deviation of displacement.